how we solve frames that have side sway. When side sway is allowed, it means when we have side. It means when we have sides. In frames, in beams, if we have side sway, we said there is one support will settle, واحد من السبورات بتنزل. That settlement should be known. From that settlement, from the tables on the right and the back of the cover of the book, we can calculate fixed end moments. Then we put them in the right location and you put in the solution. Here in this case, you will see it's different. In frames, the procedure is kind of the most difficult thing maybe so far. Let's see it. So we have now side sway and frames. Okay, we have the following example. Look, if you have a frame like this, you can have fixed or pen, anything you want. Fixed or pen, the same solution. Let's just do pen and pen. And let's have EI constant. And let's have this length 12 feet. And this height 9 feet. Good? 9 feet. Now how we may have, how we can have side sway? You may have distributed, don't try this, this is not the example. You may have distributed load. Uniformly distributed load on the frame. Is there any side sway? This frame is not braced against side sway. If you have any lateral load, it will sway. لو عندك أي load جانبي هيتحرك للجانب. So it's not braced against side sway. مش مدعم على الميلان الجانبي أو الإزاحة الجانبية. It's not braced against side sway. How you brace it against side sway? By having support here to prevent the movement. Or connect this one to a beam, then connect it here. So this could be a connection to a wall, the jidar. Or you may have braces like this. Those braces, they brace it. They prevent the movement, or the movement will be very small.
As a truss?
No, forget it. This is in seismic design, earthquake design. Diagonal braces. Or you may have a shear wall in the middle. Look. Shear wall. If this one want to move, the shear wall will hold it, will prevent the movement. Okay. These are lateral systems. We use them in lateral design, earthquake design, and some high wind design. You may use the X braces or something else. Or you may have just something like this. Okay, but this one, is there anything prevent the movement, the side movement or the sway? Nothing. Good? But under this loading, there will be no side sway. تحت هذا اللود, there will be no side sway. Good? Wait, in the middle? If the load is symmetric on the beam, there will be no side sway. Any load not symmetric on the beam or any lateral load will cause side sway. So if you have the following, this is what I solved in the second class. If you have something like this and lateral load here, you can solve it twice. You can say this frame, I will solve it, this, without the lateral load, plus the lateral load. And all the answers will be sum. اجمع الجواب at the end. نون التون إذا اثنين أعطوني كلوك تجمعهم. واحد أعطاني كلوك، واحد أعطاني كلوك، تطرحهم. Good? If you have lateral load here and something here, you can solve this plus this. Or you have lateral load here, anything. This plus this. Good? Now, what if you have the following? This is what I will solve today. You have the following. You have 20 kilonewton per meter. You have then, if it's kept per foot, 20 is too much. Yeah, let's do this. This is 9 meters. 9 meters is too much. Okay, so this is 3 meters and this is 4 meters. 3 meters, 4 meters, or 9 feet, whatever. But let's do this. 20 kilonewton per meter. The units as long as they are dimensionally compatible, you can solve the line units. This is A, this is B, C, and D. And if you look at this one, the load is not symmetric. Yani you can tell, you know, this load here will cause a sway to the right, more to this side. If this one was this way, it will cause a sway to this side. Good? So how do you solve something like this? Let's see. يعني what's the, let's follow the procedure. يعني سوي اللي تعلمناه. Let's follow the procedure. We do KAB equal KBC. صح؟ KAB equal KCD equal 3EI over 3. So it's EI. KBC equal 2, not 2, 4 EI. It's not symmetric. When you have symmetric, you modify 4 EI. Excuse me. You can modify it and solve half. يعني modification, if you modify, you have to solve half.
لو كان اللود مش من درجة أولى يعني من درجة زيرو.
وتساوي اللود uniform and منتظم. If you put 2 EI, you have to solve half of the beam, نصه بس.
تمام بس هو بس النظام ما بيظبط بس إذا حطيت اللود بيصير.
مش هيك قصدي يا اسمعني. مش هيك قصدي. إذا عملت هاي distributed load وحسبنا 2 EI over L، إذا حليته كامل مع بعض غلط. If you modify for symmetry, you have to solve half of it. غير هيك بصير يجيك من هون بروح لهناك ومن هون بروح لهناك، بصير غلط. That's the symmetry. Symmetry means modify this and solve half. حكيناك هذا الشيء. Anyway, this is 4 EI over L. It's not symmetric. يعني you don't need to think. هسه لو كان symmetric and you use 4 EI over L, you have to solve the full beam. بيطلع معك نفس الجواب، مش حليت لكم واحد هيك وواحد هيك، نفسه حليت لكم اياه مرتين. ليش بتستغربوا؟ ولا مش قاريين؟ مش قاريين. طيب, what's the distribution factor now? This one, 1. This one, EI over 2 EI. On 5. This one, on 5. EI over 3. يعني ظبطت الارقام عشان يطلع معي. بس عشان نسهلها. With any number, you can have any number. 1, 4, 1, 3, بس you can have any number. This one, 0.5. This one, 0.5. And this one. Yeah, you know what's this one? Yeah, distribution factor. This joint is a pin. It distributes all the moment. It doesn't take any moment. This one, its bar, حصته من unbalanced moment at this joint is half for this. It's share. What's the stiffness of the joint? 1 times EI. Stiffness of the joint is 1 times EI. EI plus EI. Sorry, EI plus EI. 2 EI. This is the stiffness of the joint. The stiffness of the member is EI. This is the distribution factor. Distribution factor. Sum of the distribution factors around the joint is 1. Good? Now what's the fixed end moment? This one doesn't have any load. No fixed end moment. This one, no fixed end moment. This one has a fixed end moment. If you go to the table, you fix this and this, you will get WL square over 30 on this end and WL square over 20 on this end. This way and this way. يعني which one is bigger? Over 20 or over 30? Over 20. يعني هاي بيكون مومنت عندها أكثر. This would have no moment. Good? You have it in the table. So WL square over 20, you have 20 times 4 square over 30 here. And 20 times 4 square over 20 here. This is minus, this is plus. How much this number?
10.6.
10.7.
0.66.
0.67. Negative. And this one is 16. Positive. These are the fixed moment here. Here. Now let's make our table. Let's make our table. J joint, M member, DF distribution factor. These are the information we need. We have A, 1 member. We have B with 2 members. We have C with 2 members, and we have D with 1 member. So you have this, then you have this, you have this, you have 2 members here, and 2 members here. Two lines. Once you set up this one, you should have no problem after this. AB, BA, BC, CD, CD, DC. Distribution factor 1, 0.5, 0.5, 0.5, 0.5, 1. Good? Distribution factor. Now what's the fix in moment? No fix in moment here, 0. Here, 0. Nothing, nothing. 0, 0. Then we have BC. BC. This is BC. Minus 10. 66667. And here we have CB. This is CB. 16, 0, 0. Distribute. Distribute. Now this joint. No, not this and this. Some of you will add this and this and that. No, this is the joint. This is joint B and this is joint C. Joint B has unbalanced moment of minus 10.67. We apply 10.67, distribute. So it will be 5.33, 5.33, positive. This one will be minus 8, minus 8. Good? Good? Is there anything will be carried over to this? No. Nothing, because it's pen. No carry over here. Is there any carry over here? No. Nothing, but there will be a carry over between those two. Min hon, there will be a carry over to this, and there will be a carry over to this one. Carry over factor is half. Yani half of this will develop here, half of this will develop here. So this is minus 4, 2.66,
2.66.
2.67. Positive. Now you have the same cycle. Yeah, you have like what you did here, you do it here. This joint has unbalanced minus 4. There will be 2, 2. This one, what's half of 2.67? 1.33. Good. شوف هم بيجيبوا علامات عالية يا جماعة، بقول لك ماينس. I apply minus 2.67. يعني هاي small mistake يا جماعة والله يترون everything. يعني حرام نضيع كل الشغل على انك ما تنتبهش this is minus. It's minus. We apply minus then we distribute. يعني pay attention to this. Okay? هذه يا جماعة شباب بتنقص نصاص ووزع. يعني كل مرة بنقص ربع. صح؟ نص ونص بروح لهنا. ربع. Now, carry over. And once you have this one, you know. And the first cycle, be careful. See where is if this one was fixed, by the way. If this one was fixed and fixed, there will be a carry over here. And the carry over here. But the good thing, it stays there. بيضل هنا. ما برجع بتوزع. ما لهاش بالانس. بيضل هنا. Good? So this and this is 1. So when you carry over, the same sign. When you balance, the opposite sign. إشارة عكس هون نفسها. Right 665 يعني 6 or 6 7 بس this one. So this one is 1 minus 0.5 minus 0.5 and this one minus this is 0.33 0.33 right 3 with the positive sign, half here and half here. Let's take 2 more and stop. Then we will add. Let's take 2 more. 0.25. And this one? 0.165. Now balance minus 0.125 minus 0.125. No, this is minus here. See, this is minus, so this is positive. And this is positive, now this is minus. 83 minus 0.083. Carry over. Half of this is minus 0.04 and half of this is 0.075 or 0.61, right? Half of this is 0.061. And the last step, then balance this one, minus 0.03 minus 0.03, and this one is 0.02, 0.0, and you can stop here. Why? And why? We expect the moments to be like within 16 and 10, right? The moments within these numbers, and our moment values, 10 here, 16. We don't have like 160 or like 107 here. So when if you have like something like that, then you can stop here. Depending on how significant. But once you are below 0.1, you can stop. It's your judgment. We said this is approximate method. You can carry it all the way. If you have Excel sheet, if you run a program Excel sheet, it will give you the exact answer. All that, but approximate. Who cares like about this? Very small amount. Very small amount. Anyway, now what's the sum of the amount? Here you see this?
7.8.
Here, 7.8. This, so this is 0. This should be minus BA and BC. This should be minus 7.8. You have that? واحد ثاني ما اشتغل. Need 2 guys to verify. Or 3 عشان واحد يرجع. This one. Ten. 9.1. So 10. So minus 10 here. We know that's approximation. And this is 10. Good. And this is 7 minus 7.8 and this is 7.8. Did you get this? 7.8? Sure? Someone else checks. This one's good, right? So someone check this before we go. Good.
على السي دي لأنه موديفايد.
لأنه بن.
لا السي دي مش على
وين السي دي؟
بس دي هون ما وزعناش في أول فترة. يعني هون السنة كمان ما وزعناش على السي دي. يعني هو
كيف توزع من نفس الجوينت؟ هاي نفس الجوينت. كيف توزع على الجوينت الثاني؟ هاي نفس الجوينت يا عمر.
السي دي وزع.
كاري اوفر لهون للجوينت الثاني. هاي الانبالانس هون. كيف كمان كاري اوفر هون؟ كاري اوفر للجوينت اللي بعدها. يا هون يا هون الجوينت هاي ما في كاري اوفر بين الجوينت ممبرز. هذا في ديستريبيوشن. نو ديستريبيوشن انا ما بعملش موديفايد يا جماعه انا بعمل موديفايد. هذا استحاله. الموديفايد هذا هو نوت في البدايه لان ما عملش سيمتري. يعني الموديفيكيشن مور امبورتنت سيمتري. الكاري اوفر للجوينتس between the joints هاي الخطوط. This is the carry over between these lines. Not within the members.
صح. صح.
Good. طيب خلينا نشوف شو عندنا. Let's put the members. So this is A, B, B, C, C, D. What did we calculate? This is 0. VA is 7.8, it means clockwise 7.8 on the tail. 7.8. This one BC minus 7.8 minus or 7.8 in this direction. This one is 10. That's 10. Okay? And this one minus 10 minus 10. So this is minus 10. So not minus, so this is 10. Means counterclockwise. Good? So we know we have shear here, we have shear here, we have axial, we will go to the axial. But now we need the shear. And we have shear here and shear here. We have shear here, shear here, shear and shear here. Good? Now, how much is the shear here? So the length here is 3 meter, and this is 4 meter, and this is 3 meter. Remember, there is the load here. Right? There is a load of 20. So this shear is the moment divided by the length. Sum of the moments divided by the length. So this is this way. So the shear here will be here, this way. So they create counterclockwise. If this is this way, it means this is this way. You see how much is this? 2.6. Everything is in kilonewton, comma, meter units. 2.6.
3.3.
This way, 3.3. That means this one is 3.3. Now you stop here. Give, we come. So what's the shear at A? Is the reaction at A, right? How much? The reaction in its direction. So we have 2.6. So how much the reaction? How much AX? 2.6. So AX is 2.6. And how much DX? This way, right? 3.6. So sum of the force in the x direction equal to 0. Are they equal to 0, Yama? So there is something. And this is the middle. To do this, in order for the equilibrium, it means there is a reaction developed by preventing sway here of the amount of the difference between them. When we have a sway, how we get the equation? Sum of the shears. In this case, sum of the shear equal 1. Believe it or not, this is sum of the shear equal 0. In this case, you can do it in the slope deflection. If you have a problem like this, P sway. There is a sway. VA plus VD equals 0. And VA you related to the M. VA and VD you related to CD. Then you have one more equation between the moment here and the moment here. So that was in the slope deflection. Now, is this correct here? Minus 10? Minus 10. Minus 10. So that's minus 10, right? So this is minus 10. This should be this way, right? Reaction is in the direction. Okay. So R here, something called it R dash here. To prevent this, it's kind of, you need to apply, or we restrain it, we prevent this way by applying this pen or roller. Roller, you don't need to apply pen. Roller here. The difference in the two shears is this value here. 0.3. So R dash. So this is 3.3. 0.6. So if we are switching to the right, R dash plus 2.6 minus 3.3 equals 0. So R dash equals 0.7. Why to the right? Why there is a reaction to the right?
عشان يصير صفر. عشان يصير صفر.
No, but I'm expecting it not.
الشمال.
I'm expecting the reaction to be this way. This goes this way. We have it here. So this one will be this way, right?
دكتور ما ممكن لانه الرياكشن اصلا بيمنع السويك يعني بيحاول يمنع كمان
السويل والشمال
يعني السويك راح يروح
اليمين.
والرياكشن مع
السويل
اليمين.
والرياكشن مع والرياكشن مع الشمال
كيف الرياكشن؟
طيب بس احنا عندك 3.3 لهنا
يعني المحصلة تبع 2.6 و 3.3 لهنا تمام وآر كمان لازم تكون هنا صح؟
If you have support, it will be something. We will apply 3.7 to this direction. But I'm trying to think. And this one resulted in unbalanced force this way. Unbalanced force this way. It means there should be a force applied in this direction, right? To balance this. There should be a force applied in this direction to balance this, which is 0.7, the difference between them. To hold it, right? Now, what you do, you remove all the load, and you see the effect of the 0.7 or R dash on the frame. And you solve the frame with R dash only now. You solve the frame with R dash only. Good? This is 5.3 minus 10. This is minus 10. And this is تقدير انه هاي 30 وهاي 20. تأكد والله.
مش موجود بالشيء.
موجودة.
شرط في هو ده فيكس.
هو فيكس ولا فيكس؟
بدك شو اسمه لا بدك معنا المرة الماضية.
صح بس اللود بالعكس
It's okay. يعني the one with the high load is over 20. The one with the small load is over 30. أنا هاي بعد بخلط فيها easy شباب. So 20, that's 20.
الدكتور صح
30. Okay, good. Good. So this will take it to this one. And is it possible that this one will sway the frame this way? يعني هذا اللود will sway this way? يعني هيك الحل. It will sway this way.
دكتور اسمع انت اللي بتعمل ليش
طيب دكتور
بتحط شيء زياده هون بميل على It's all I think. But according to this answer here, there is a reaction developed here. Yani to do this, you prevented the movement by this reaction and the reaction here. So when you solve your truss, you have to apply the reaction in the other direction. You have to apply the same amount of R dash in the other direction.
ليش؟ لأنه أصلا المحصلة تبعت
هون.
اللود رح تكون أقرب لها. نتصور يعني تعمل زي مومنت أو زي شيء.
That's what we got. أنا مش داخل مخي but this is what we got.
مرة خلاني صراحة لو طلع حتى مومنت وصلت له لا هي نفس الشيء هي شو كذا يعني تفرق مع ضامن نفس الشيء.
Our case is fixed, right? That's fixed, and that's fixed, right? So this is the case. You have W fixed, still let's go about 20. The big side is this. You will get the same answer if you do this minus المثلث الثاني إذا بدك. It will be the same. يعني هذا بعكس هذا. Good. So according to this, we realize that this load will cause the sway this way. So to hold, we hold it this way. So when we apply the load on the frame, to prevent this sway, we develop a reaction to the right. This is the calculation of 0.7. This 0.7 does not exist. مش موجودة. Does not exist. So we have to apply counter balance to this one. 0.7 in the other direction. So you have to solve your frame. You have to solve your frame now for this case. 4.7.
This count.
This one will have a reaction this way, right? There is nothing here. Should be 0. So we have to apply opposite to this one to make sure there is no load here. Okay? And I was expecting the reaction to be this way, then I will apply force this way. But this is what we get. This is what we get. Good? Now this is not the case. This is not the most difficult thing. This is easy. We know. We put a support, حطينا support, صار عندنا reaction. بدنا نجيب السبورت أنا مش موجودة، نحط reaction معاكسنا. ونحل. We know this. We apply an opposite reaction with the same magnitude. Okay. Okay. If you do this, the distribution factor is the same. And I will solve in red now. The numbers are the same. The distribution factor are the same. But everything is the same. You have A, B, C, D. Everything is the same. Now, what's the fixed moment? What is the fixed moment? 0. The fixed moment, he says the fixed moment is 0, 0, 0, 0, 0. So there's nothing? في load. There is a load here. The fixed moment is 0. He's right. There's a fixed moment here, nothing. Is there a fixed moment here or here?
هسا أنا باخذ المومنت عند ال A، ده هو ال A وده ال A.
وين المومنت؟
أنا باخذ مجموع المومنت هذا أنا بتحول باخذ مجموع المومنت عند A تساوي لك 0. راح أخلي قوة من D، ضل عندي دي واي بس.
دي واي أنا by the way those I can find them للبداية those we can find them. The only thing we cannot find is the x. هذا الفريم اللي بتاخذ مومنت تون equal to 0. You find dy. Some of the forces of the y direction equal to 0. You find ay. Easy. But
راح يطلع 3 كمان نفس الشيء.
No, this is the x. This is the x. The x Okay. Listen. This is the technique. This is the technique. This one will cause moment, fixed in moments here. Why? Because you have psi. Psi, location of this one, which is delta here and delta here. There will be a sway. Again, a sway. Does it give you a moment? A fixed in moment? Does it? Yeah. Look at this. If you have a sway between two supports, there will be a fixed in moment developed at both one in the same direction. If both spans were fixed, they would contain kind of fixed. Equal 6 EI psi over L. Thus we know psi equal moment equal 6 EI psi over L. 6 EI delta square, delta over L square. If you have fixed. So this one doesn't have psi. So the fixed moment here and here is 0. But there will be a fixed moment here and a fixed moment here. So your case is on the right. Your case is on the right. You have one pin and one fixed. The fixed moment, if one of them goes delta, or if the pin goes delta, there will be a fixed moment at the fixed. إذا والله إذا البن نزلت قد ما تنزل. في moment عند البن 0. Pin doesn't develop any moment. There will be a moment at the fixed. Equal how much? 3EI delta over L square. You see it? 3EI delta over L square. And then remember, I will go back to this one. Both of the moments are in the same direction. Both of the moments, the fixed moment here in this case is in the same direction. You see them? عكس psi. إذا ساينز تحتهم بيكونوا عكسها. Opposite to side. Opposite to side. Same.
Moment عكس side.
The fixed moment developed by side is opposite to side. So what I'm saying here, yeah, you apply side here. What is the fixed moment here going to be? عكس side. Side لفت here. Come عكس side. Opposite to side. Good. So how much this one? We said 6 EI, sorry, 3 EI delta over R squared. 3 EI delta over R squared. This case, because you have pen and fixed, 3 EI delta over L squared. Our case is fixed pen, not fixed fixed. This is for fixed fixed. That's not the problem. So, okay. So how much? What's delta? What's delta? هذا محضر؟ هذا مر عليه؟ حكم محضر؟ أعطيه علامة اللي بيعرف شو نعمل. مش عايزها. عشرة. أو 100 أو 1000 أو 1 أي رقم بتحبه يعني تحب تستخدمه 10 100 وكذا. So we will assume 10. Listen, we will assume 10.
Delta.
Fix the moment. Not delta. Delta you can calculate now. We will assume the fixed moment to be 10. So if you want delta, you can calculate delta. It's 10 times L squared divided by 3. Yeah, we can do it. But we will assume it 10. Then we will solve how much the 10 will give us fixed in moments. Yeah, so from the 10 here, we will calculate fixed in moments. Right? Right? So, then we will calculate how much the shears. Right? The shears, the sum of the shear will give you R. If R is the same, that's your moments. If R اللي بتطلعها من 10 was مثلا 135 معناته اللي بتعطيك اياها 0.7 twice. المومنت بتعطيك اياها 135. Okay, just let's finish. So I will assume it 10. Right? I will assume it 10. You can assume either 10 يعني why not 100? الصف الثاني أنا assumed 100. Why? لأن المومنتس كانت عندي around 100. Now my moments here 16, 10. Assume any number for the accuracy. For the accuracy, you can assume it 1. You can assume it 1 million. But for the accuracy, you assume something within the values you have. So we assume 10 here. We will calculate these moments here, the end moments, exactly this and this and this and this and this one based on the 10. Then based on the 10. You can have 15. Then make your solution easy. Good? 10. Then you calculate this and this. You add them. If they give you 1.7, good. If it's not 1.7, like مثلا 5, R5, the moment that you will get by the 5 will be 5 over what you get from here. Sorry, 1.7 over 5 times the values you get from the 5. Let's do it. So where is the moment? BA. That's BA. How much? What is the fixed? 10. Where is 10? Clockwise? Yes. So this is 10. 10, not 100. And D. CD. What is CD? CD here. So this is 10. Good. Now balance. This one. Minus 10. Minus 5. Minus 5. This one. Minus 5. Minus 5. Carry over. Minus 2.5. Carry over. Minus 2.5. balance 1.25, 1.25, 1.25, 1.25. Carry over 175, 175. Balance minus 0.3, 75, 6, هون
75 غلط ما هي 1 ربع.
هاي غلط؟
لا الواحد ربع صح.
1 ربع 0.75
غلط يعني alright. هاي 16 25 وهاي 16 25. half of it 0.3 1 خلاص 131 1.31 1.31 1.31 كله minus all minus then carry over minus 0.15 minus 0.15 then 0.075 0.075 0.075 حتكون symmetry يعني. You can carry it over one more time. 0.037 minus 0.037. Then if you realize that half of it will be here, 0.015 or 16. 0.016, 0.016. You can continue if you want or stop. Now add them for me. What? That's fine. That's fine. Add them for me. Now it will be the same number. واحد يبدأ بالأخير، واحد يحل. Someone check this. And so on. It will be the same number.
6.033.
6. I want 6. 6 يكفي. Positive. And this one should be minus 6. Huh? تمام. Minus 6. 6. ولا minus 6 هون. هون CD. هون minus 6. هون 6. Good? This will be. مش كاتب بعد ما عملناش بس انا هقول لك. Still, wait, just wait. I assumed 10 here. We did not do anything yet. We got these things. Now what's due to this one, what's MA, MBA? 6 clockwise, right? Yes. That's 6. What's BEC?
minus 6.
This one. This one. Minus 6. Good? Now what's the reaction in here? No, the reaction due to 6 here. The reaction due to 6. 2 like this, right? And this one. اوكي هاي مش هتأثر يعني. ما راح يأثر. This one here ما راح يأثر. لا هاي مضبوطة. minus 1.15 يصير 0.075. At the end يا جماعة it will be the same. مش not a big deal يعني. It will be the same answer. It will be the same answer. مش big deal.
CD plus 6
CD 6 هسه صح الشباب. هسه صح الشباب. اياها. That's good. 6 minus 6 minus 6 6. So now we have 2 and 2. This one? This one? Minus this, you are right. It's not the right one. But look now, this is the most important thing. So this one, by assuming 10, the fixed moment due to this side is not due to side is not 10. We got 2 and 2. We got 2 and 2. So how much R for this? 4. What's our R? 0.7. اسمع آخر شيء. So our R is 0.7. The one that will give me 10 is 4. So my 0.7, how much it will give me? These moments, how much it will be? This moment here. 0.7 over 4 times. All of them. Now you are accurate. Now this is the case. This one is, the good one is, or the correct one for the 0.7 is, what, 1.75?
1.05.
1.05. Take it here. 1.75, take it here.
1.05.
Check here. 1.05. 1.05. 1.05. And you do this at home. Now, what do we have? How much now? 1.05 plus 7.8. Goes both in the same direction. How much? 8.85. This one. You have 7.8 and you have 1.85 in the same. It will be the same. 8.85. Now this one, we have 10 clock and the small one. So this one will be 10 minus 1.05. 8.95. And it's almost the same, but it's like an approximation. This one. 5. Then you can find your shear here, your shear here, your shear here, your shear, and your shear. And this shear will be axial here, and there will be an axial here. This shear will be an axial here, and this one will be an axial here, and this shear will be axial in the column, and there will be a reaction up. حلو خلاص انا افضل هنا تمام فهمت الفكره خلاص you assume 10 or 100 or whatever good in the direction you assume يعني if it's way to the right always downward due to this one is opposite good then we calculate based on this 10 we calculate the moments all the way and we find that the lateral force causing this one is a number, 4. So the moments that will be caused by my lateral force is ratio. R dash over this times whatever numbers you change. Then you put them back and